Hello everyone, welcome to Stick Engineering classes, and today I am going to teach you about amplitude modulation. In last class we will look at what's the modulation, and we will look at its types of analog modulation, and today we will talk about amplitude modulation. In case of amplitude modulation, the amplitude of carrier signal is changed by the matched signal. So let's look at its figure. This is a baseband signal, or this is the matched signal. Okay, it has time in its x-axis, amplitude in its y-axis, and am is its amplitude. Now this is carrier signal, high frequency signal, carrier signal. Its amplitude is AC, and now after modulation it will look like this. Okay, like this. Here the amplitude of the carrier signal is changed by this baseband or matched signal. Okay, so it's called as amplitude modulation. Now let's look at the mathematical expression of amplitude modulation. Let us suppose that MT is the matched signal, and its mathematical expression is AM cos 2 pi FMT. And likewise CT is equal to AC cos 2 pi FCT. Here AM and AC are the amplitude of masses and carrier signal respectively. Likewise FM and FC are their frequency. Now after modulation, this is the equation of amplitude modulated signal. Okay, this is the equation of amplitude modulated wave. Here the amplitude of carrier signal is changed, amplitude is changed. Okay? Now let's talk about modulation index. Modulation index, it states the level of modulation that a carrier wave undergoes. Okay, so let's rearrange this above equation. S is equal to, let's bring out AC, and this term AM by AC is called as modulation index, represented by mu, and let Amax and Amin be the maximum and minimum amplitude of the modulated wave. Okay, the Amax is represented by AM plus AC, and Amin is represented by AC minus AM. So under some mathematics, we find out mu is equal to Mx minus Amin by Mx plus Amin. Now let's look at the power calculation of AM wave. The modulated wave is this, and it can be represented as this. And now the total power will be carrier power plus upper sidebands power and lower sidebands power. We know that power is equal to Brms by R. Power is equal to B square by R, and Brms square by R, and Brms is equal to B peak value by root 2, and this will give PC is equal to PC's amplitude is AC here. That's why it is Bm square by 2R. That's why in case of Bm we will put AC, and AC square by 2R. Likewise for USB the amplitude will be AC mu by 2. Actually this is the equation for carrier signal. This is the equation for upper sideband signal, and this for lower sideband signal. The modulated wave will contain upper sideband, lower sideband, and carrier wave. So the total power will be equal to their individual's power. So USB is equal to AC mu by 2 over root 2 whole square. This will give AC square mu square by eta. Likewise PLSP will also give AC square mu square by eta. While adding we will get this as a final result. Let's look at a numerical. I think you will understand it. So guys, if you like my video, you can subscribe to my channel and press the bell icon. Thank you for watching.